purpose of today's video is to go through Newton's 3 laws of motion, which you were asked to read out of the textbook and complete in a foldable earlier this week. So we're going to review those 3 different laws of motions. Right now, I'm going to ask you to please take out your foldable so you can follow along and add anything to your foldable that you learned from this video. So Newton's first law of motion. Newton's first law of motion is pretty simple. It actually says an object in motion will stay in motion unless acted on by an unbalanced force. That means that if something is moving, in a perfect world with no friction, if I was driving my car would continue to move and just continue to go, even if I wasn't accelerating, unless something came in and tried to stop it, a force was applied. And we know that that's true. If we ride a car, if we roll a ball down a hill, even if we get on like a grassy hill on a nice summer day and roll down the hill, we know eventually we're going to stop. And that happens because an unbalanced force is applied. That unbalanced force is applied. That unbalanced force, if I'm rolling down that grassy hill, is friction. If I'm driving in a car, the unbalanced force is some friction from the road, but it's also going to be the brakes that I apply to my wheels that help me slow down. That's Newton's first law. This also is true of an object that stays at rest. So an object that stays at rest is going to stay at rest unless acted on by an outside force. So objects tend to want to keep doing what they're doing. We know this is true in the natural world. And we have a name for this. And this name for this is called inertia. So inertia, the definition, is the tendency of an object to continue its same motion. So that means if something is sitting still, like the rock that this woman is trying to push over, inertia is going to be the rock wanting to stay still. The rock doesn't want to move. It's not moving. So the rock's going to have this tendency of, I don't really want to move. I'm going to sit here. Unless, she is like an Olympic bodybuilder and has a couple of friends who could help push it over, who have an unbalanced force strong enough to push it over. Same thing happens with this rocket. If we were to send this spacecraft up into space and send it going in space where we know there's no friction, there's no air resistance, if we set our jets going a little bit and then turn them off, that spaceship will continue moving forever and ever and ever in space, never slowing down, because there's no friction. And since there's no friction, that inertia is going to keep that rocket going forever and ever and ever. And we've sent spacecrafts into orbit that done this. Not that have people on them, but we've sent satellites and other things to go explore deep space, and we send them out to just keep going and going and going. Even some of our ships that we send to Mars, like the Mars rovers, haven't had a lot of rocket fuel on there because they'll start them going at the speed they want, and then they'll turn off the jets, and inertia will keep the spacecraft moving until it gets to the planet that we want it to get to. So again, inertia is the tendency of an object to continue doing the same thing, sitting still, moving forward. That all ties into Newton's first law. Newton's second law, you're probably looking at your foldable and going, man, this is a confusing law. I don't get this. This is where you might want to rewrite the law, because Newton's second law is pretty easy. I rewrote it for you. It said objects with more mass require more force to push them at the same speed. Let's think about that statement. Objects with more mass, so heavier objects, require more force, a harder push, to push them at the same speed. Is that true? Think about it. If you go to the grocery store with somebody and you start out with a cart with nothing in it, and then you keep adding food to the cart, do you eventually have to push harder to get that cart to move at the same speed? You do. You absolutely do. Okay, it's why when you put extra things in your vehicle, okay, it takes more acceleration. You have to push in the acceleration more to get the car to go at the same speed. Heavier vehicles aren't as fuel efficient because they have more mass in them and they require more force. So I like this little comic here because it demonstrates Newton's law perfectly. Okay, this little boy is going to use this penguin to help demonstrate. So this penguin right here is really heavy. Going to take a lot of force to move him. Okay, but this penguin's really small, easy to lift up. Not going to be a problem to move the penguin. Heavier things are harder to push than lighter things. Okay, that's Newton's second law. Heavier things are harder to push than lighter things. All right. Newton's third law, also a pretty easy law. Hey, Newton's third law says for every action that takes place, there's an equal and opposite reaction. Okay? You could also say for every force that is applied, there's an equal and opposite force in the other direction. So I think the easiest one is to start with this rocket over here. Okay? The action for a rocket taking off into space, okay, is the engines starting and they push down. Have you ever noticed that? The engines of a rocket push down. The action is the pushing down. Okay? The reaction force is a reaction of pushing the rest of the rocket up. So the action force is the engines pushing down. The reaction force is what's used to take the rocket into space. You're going to see that rocket go up. Okay? We can see this too if you're playing with like a playground ball or a bouncy ball. I don't know if you've ever played Foursquare. Okay. When I was in middle school, we actually had to do a Foursquare unit in gym. Okay. But if you take a playground ball or a Foursquare ball and you send it down to the ground, you're applying a force and it hits the ground. It hits the ground with a force at this angle. Well, the angle going back up here, this longer arrow, that is the equal and opposite reaction force of the ball. So the ball hits the ground. The reason the ball bounces back up is because the ground pushes back on the ball with the same amount of force. So try this. Push down on the table or the counter or floor in front of you. You're applying a force, right? Are you pushing through the floor? No, hopefully you're not pushing through the floor. You're not pushing through the counter. If you are, there's a problem. Okay? But when you're pushing on that counter, the counter is pushing back at you. The floor is pushing back at you. The table is pushing back at you. That's Newton's third law. For every action pushing down on the counter, there's an equal and opposite reaction. Okay? That means it's going to have the same strength. So if the action of this engine from the rocket going down was 5,000 newtons downward, the reaction force pushing up would be 5,000 newtons upward. Okay? So in review, Newton's first law says an object in motion will stay in motion unless acted on by an unbalanced force. Newton's second law says heavier objects require more force to push them than lighter objects. And Newton's third law says for every action, there's an equal and opposite reaction. Okay. Please remember to complete the rest of your blended learning day